first number here is then always describing the payout of actor A. The second, the payout for actor B. So when actor A and B throw heads, then actor A gets 1, and this is basically then at the cost of actor 2. And there is no equilibrium in this game because, yeah, basically it goes on and on, and actors basically don't have strategy or preference for either one or the other, because so no matter whether actor B here throws heads or tails, then actor A sort of is indifferent to what he or she is supposed to do. And this is a zero-sum game in the sense that whatever then one player gains, the other one loses. And this may be then be a model for a distributional conflict. And this is a different kind of logic when compared to the coordination game whose payoff matrix you may see here. So in this game, think about which lane you should drive on in a given country, or which lane a country should decide to drive on. Again, with the 2 players, I can drive on the left hand side or the right hand side. Sort of the car that's coming closer and closer can also drive on the left or right lane. And again, the first number describes the payoff for actor A, second number in each cell, the payoff for actor B. And the arrows which I drew in here, they basically show where actor A and B eventually move to which sort of decision, given the decisions of the other actor. So let's take, for instance, the case where actor B decides to drive on the left lane. So I am actor A now, and I can decide either to drive also on the left lane or to take the right lane. But when I drive, given that actor B drives on the left side, then I basically have no payoff at all. At worst, I have an accident if I decide to drive on the other on the right hand side. So I also choose to drive left rather. This gives me a payout of 10 in this sort of fictional payout. The story then being that obviously I avoid a collision. And this is the same basically for the case where B chooses to drive on the right-hand side. I basically follow the same logic. I copy what the other actor does. And this is a symmetric game. So A and B are equipped with the very same preference set. And therefore, we have a game that has also not just one, but 2 equilibria, where it's either the left or the right-hand side. It's sort of the first move that decides where the players eventually end up in. So this is a one-shot game, but let's say more complex forms of then game theory also involve iterative games. Okay, so basically, in more sociological terms, what this coordination game shows is that they are, if you want, low-cost social problems where the solution is relatively unimportant. So which solution is taken is unimportant. It's important that a solution is taken. And this may be decided conventionally, right? We just decide it's a convention. We drive on the left-hand side when we're in Great Britain, right-hand side on the continent. But we just need a convention. So the solution to these coordination games, I think, is very close to what a functionalist would call an institution. It's also, I think, close to this background condition of institutions that I mentioned in the context of the phenomenological tradition of institutionalism. And yes, basically this assurance game that's solved by these focal point is another game of that kind, or also the Battle of the Sexes. Let us come to one of the most famous games. This is the third type here, in a way, problem of collective action that's also modeled in this way. And probably most of you know already about this game, so we'll make it short. We have the situation where there are these two men charged with a violation of law, held separately by the police. And now comes the sheriff and proposes the following arrangement. So if one confesses, the other does not, then the former will be given a reward of 1 unit, and the latter will be fined 2 units. If both confess, each will be fined 1 unit, right? So this is the worst case for the two sort of potential criminals here. And the third one is they are both silent, they don't confess, and they just move out. Police doesn't have any evidence. And this maybe modeled the situation here as a two-player symmetric game again, right? Player A and B, 1 or 2, where the following payouts define the outcomes of whether actors confess or do not confess. So let's briefly go through it. Let's imagine that actor 2 here does actually confess, right? I am actor 1, what should I do? If I do not confess, so I'm really worse off. I go to jail, and the other one here moves out of jail even, so best case for everyone. If I confess, however, I'm better off a little bit. We both have to go to prison, but at least I don't take the full sort of responsibility, and the other one isn't going out. So the same. So then actor 2 does not confess, let's say. Here in this case, what should I do as actor 1? If I also do not confess, then, I mean, we're both going out of prison, good thing, but I'm even better off, getting a score of 1 here, if I do confess and put the other guy here in prison. So what do I do eventually? I have a dominant strategy, right? So no matter what the other person does, I opt for confessing. This is a symmetrical game. Both actors confess. So all of these arrows here point into this one first cell of the matrix, which is then also the equilibrium outcome here, where when you sum up all of these outcomes, right? So take the perspective of these two actors together, then they are landing here in the very worst situation where they both have to go to jail. They get a -2 collectively. Here they would get 0. And in these other two cases where one confesses, the other doesn't, they get at least a -1. But the equilibrium then is they end in the -2 corner. They collectively, if they were just one actor deciding, with a collective rationality, instrumental rationality at least, they would have opted for the non-confession situation where they would have gone out of prison and would have been better off. And the interpretation then that is associated with this prisoner's dilemma, or the logic also of collective action, is that due to this incentive structure of individuals defecting, so in this case confessing, and basically going for the individual rationality of maximizing their own gain, they fail to implement a collective rationality in favor of their joint best outcome. And this kind of logic then can be applied to many situations of collective action. Has been applied to the arms race, right? Every nation unsure about what the other nation does does it respect an arms treaty or not, secretly starts to invest more and more in arms, spending more and more money, instead of respecting the agreement. And individually, then the dominant strategy is to overinvest in arms. And everyone lands in this corner where there's an overinvestment of arms and perhaps an underinvestment in welfare, whereas the collectively best outcome would have been to just not spend more money on arms. Same could be applied to cartels, right? The agreement of companies to, for instance, fix prices, where every company has an incentive to undercut prices again to get a little bit more volume, which does not work when everyone does it, because then volumes are decreased again, but prices are lower, and the cartel is worse off at the end. And Garrett Hardin's Tragedy of the Common is also another related instinct where individual actors do not take sort of collective costs into account. And an important sort of distinction that helps to make sense of these different also kinds of problems is this typology of different goods that economists often used, where, as we just saw, also the common goods that require sort of a collective agreement for being used or also for being newly created. Think about sort of fish in global oceans, just a forest that's collectively used, or also think about goods that have to be collectively created. So where these kind of common goods have the particular nature of being rivalrous in consumption while being non-excludable in terms of access. So global ocean fishing, anyone can fish there in the absence of a global agreement on fishing quota. And there's a rivalry involved here because whatever my vessel fishes, yours won't catch. So eventually there may be a depletion then also of the total stock, and we may be ending in a world where there are no fish left in global oceans. And this is a different kind of, let's say, collective arrangement also that may be necessary when compared to private goods, which is the, let's say, stock domain of economists, where, as in the case of food, clothing, etc., there's not just a rivalry in consumption, right? The food that I eat, you can't eat, but there's also a limited access. So that basically whatever food I have access to by buying sort of private property rights, right, that regulated over using it, you cannot access, and this is different when compared to the global oceans. So there are also goods which are not rivalrous in consumption, and here, like there are these true public goods that have both features of whatever unit I use is not at the cost of the units you use, and in this case, there's also no possibility to restrict the access, right? You cannot build a fence around the air that we all breathe in a country, and within a country also not the national